All right, so in this video, we're just going to get through as much of this as we can, and hopefully we'll have time in this video to try an example as well. So as we stated in the previous video, we use logarithms to conveniently represent the inversion of an exponential function, although, and this is actually really interesting if you're into this kind of thing, it is a quirk, a wonderful and surprising quirk of mathematical history that logarithms were actually invented independently from exponentiation in the 1600s. I won't go too much into that, but when you really do have a deep understanding of logarithms, it does become a little bit surprising that they were invented independently. But now we link exponentiation. Now we link exponentiation and logarithmic functions so closely as inverses of each other. Okay, so both exponential functions and logarithmic functions have to do with the relation between some base raised to some power, giving some answer in the form of a number, but they both tackle these relationships, the relationships between a base, a power, and an answer. They both tackle these relationships from different or opposite or inverse perspectives. So here's an exponential perspective. For an exponential perspective, you might look at some base 10 raised to the power of 5, and an exponential question would be, what is this equal to, right? What would the output of this expression be? Symbolically, this is what the expression looks like, right? Base 10 raised to the power 5. What is it equal to? That's a question from an exponential perspective, right? What is the answer to this expression? For a logarithmic perspective, it might ask a question like this: base 2 raised to what power is equal to this number, right? So we have base 2. What is the exponent that we have to raise base 2 to get 2048? That's a logarithmic question. And we usually write logarithmic questions like this. And if you were to read it out loud, you might say, okay, log base 2 of 2048 is what? But how your mind should be reading this is, I'll zoom in here, how your mind should be reading this expression is base 2 raised to what power is equal to 2048. That's kind of how your brain should be reading these logarithmic expressions here. We've already gone over how to read logarithmic expressions out loud, and another equivalent way of looking at a logarithmic expression, like log base c of x, another equivalent way of looking at that is that the logarithm is the value of the exponent that we raise base c to get x. Or in other words, this expression right here, this expression is an exponent. This is an exponent, right? Log base c of x, what does it evaluate to? Whatever number value it evaluates to, that's an exponent that we solved for. So log base c of x is another way of writing an exponent. Okay, let's look at this first example. This is the first time we're really diving deep into this. So here it says change the following equations from logarithmic form to exponential form. So if we look up above here in this example, here again, this is what we would call logarithmic form, and we are taking this form and changing it to exponential form. So let's take a look here. First, what we should do is identify the base. So here the base is the subscript of the logarithm. So the subscript is 3. So I'm going to write base 3. And then we know that whatever this evaluates to, whatever this expression evaluates to, it will be the exponent. Right? Whatever this expression evaluates to, the answer will be the exponent. So 4 is actually the exponent on this base. And then, what is 3 to the power of 4? It is 81, which corresponds to, or is equal to, the input of your logarithm. So that's how we can change an equation from logarithmic form to exponential form. Here, in this next example, we can, if we want to take this equation in logarithmic form and write it in exponential form, first we can identify the base, which is 5. And so we can write that, 5. To what power, or what is the exponent on base 5? Well, the exponent is just going to be the answer to the logarithm, which is -2. So that is the exponent on our base. And what is the answer? Well, you can do this in your head. You could say 5 to the -2 is really 1 over 5 squared, which is really 1 over 25. Or you can just see it. You can see it. The answer to the exponential term, the answer to the exponential term is actually the input of your logarithm. So that's where the input goes, 1 over 25. So these two equations, we would say, are equivalent. They're just written in different forms. And here, finally, we can see that we have log base 2 of 512 equals 9. We want to write this in exponential form, so we take base 2. The answer to the logarithm is the exponent in the exponential form. And hey, I have no idea what 2 to the power of 9 is. Let me take out my calculator. Oh, wait, I have the answer right here. I have the answer right here. It is the input of the logarithm is the output of your exponential form. There you go. So that's the first example. In the next video, we are going to go in the opposite direction. In the next video, we're going to be changing equations from exponential form to logarithmic form, and I will see you then.